Witam po przerwie.
Welcome after the break, and let's start the last plenary session where we have 4 presentations, and the first one will be Robert Skoczyla, Salvage Architects, BIM 3D, 4D, 5D, Data Generation and Management. The floor is yours. Welcome to this first edition of infraBIM 2020. This is the last day of this wonderful event, and I represent a company, Salvage Manager, and I'm manager of the company. And let me tell you what integrated works look like with our company, and let me explain the 3D modeling, integration, and collaboration using model, and BIM 4D for planning and managing of the construction process, and we also discuss 5D for cost estimates. So cost estimation. Let me also talk about the BIM 6D for sustainable development and energy models. So these are so that's what we do in future design architecture. And I will be talking about the BIM tools allowing to work on these dimensions with their practical applications, include for Svat Hotel in Norway. The Svat Hotel, so that's the project I will be talking more in details from the BIM perspective. Svat is going to be the first worldwide hotel with the positive energy balance. It's located close to the Svatisen glacier, close to the pole cycle. It is small, and the structure is based on natural materials, and it has a rigid criterion of sustainable development with the full application of 6D BIM. And there's only one aurora available there, you can see there. Let me tell more about BIM. 3D, that's modeling. 4D, that's construction process planning. 5D, cost estimation. 6D, energy analysis and sustainable development. And the main part of the slide, we have presented iFlow and iBane platforms, which are used for individual dimensions of BIM. And I will be talking more about them later. BIM execution plan. So this is one of the major documents to carry out the BIM process as a whole. And the document includes the designing elements and all the information identified in the documents, like the information requirements, work planning, collaboration process, and providing of the BIM package. And the advanced level of BIM, currently our designs, we tend to use level 3, so full collaboration using widely available BIM standard using EFC. Checklist. For each project, we have a checklist which is appropriate for the identified BIM level and including the elements to achieve the BIM goals defined in the documents. And the folder structure in our office, very important, is the internal structure and nomenclature. And the major popular locations for each BIM specialist are BIM templates, component labels, textures, manual guidelines, BIM documents, defining BIM standards, or Dynamo scripts, automating our work. And the BIM templates, what can speed up our work and increase the quality and decreases the effort. So these are the templates which are created after each project, and they are constantly being created using our experiences to optimize and increase the efficiency of work. And the detail level and geometry and information, very important aspect which needs to be understood in a team when we need to stop. We need to stop modeling and start drawing, making drawings, and the other way around. It's very frequent that the efforts of modeling is incorrectly interpreted. Good understanding of these aspects can generate a lot of time and money savings. And let me also open Autodesk Viewer. And as an example, LOD 200 of the Svat design. Let me make a cross-section. Let me display cross-section. This is the LOD 200. We have no layers. We only have geometry, external geometry. And for your comparison, it's LOD 300. And let me also display a cross-section. And just to give you a comparison, let me zoom in. We have more details of the model. We have so PV panels. In terms of the structure and architecture, the model is more accurate. And now let me return to my presentation. What you can see here, so these are BIM tools, and these are the ones we use on a daily basis, but we also use a lot of other tools to complete the goals we have established. And BIM and GIS, in Norway, we have a very well developed platform where you can locate, you can download points, we can process them with Autodesk, Civil. And next, you can import the file to Revit where the project is being run. You scan the terrain where there are any missing elements, and in the plot, if there are any changes, so you can update the terrain doing your own scanning. And from the dot cloud, you can generate a model, and then you can process the model to simplify the geometry and or to decrease the volume of data. And simplification of the model is selected appropriately to the project level, or project advancements. And this is an example of BIM tools. And on an early stage of the concept, we carry out some simulations to optimize the designing solutions. In this case, we have been using Dynamo and Formit. And we have also been using Rhino and Grasshopper, and so having the parameters, we can carry out any simulation and input the results into the design. So this is the designing of the facade, and so the parameter is the sun exposure, and the simulation and looking for the most spectacular images from the plot in question. And in Norway, mountainous area and the natural sun exposure and underground water. So these are the analysis to start every project. And looking for optimum location and the angle for the PV panels. And we're using the 3D, we can easily define the image from all the facilities, like from the Spa Hotel rooms. So power analysis as a standard. Elevations, so facades, where the parameters are. And so we have specialists who are responsible for creating scripts, so fully controlling the design of the facade, taking into account all the guidelines. And the parametric facades. With the parametrics, we can quickly develop different versions of the solutions. And with different parameters, we can have some results to be analyzed. And with that, we can quickly check all the possibilities, all the options available, and we can take the designing decisions. So this is how we create different versions of the hotel entrance. And VDC Lab, virtual design and construction. So with a digital model, we can manage the entire construction process. And the major aspects we control, these are changes, costs, and the time frames of the investment. And VDC Viewer, that's an application to carry out construction which supports the VDC Lab, and the fully uses supports a 3D model and the schedule and the 5D cost estimate. And the major functionalities, this is full access to the BIM model and the full project specification together with and the contracts and the imaging of the construction site and the cost. So they are available on any carrier like iPad, smartphone. And this is the image. This is what displaying of information looks like on cost estimates. And the major parts, so this is a 3D model, and on the right-hand side, 4D schedule and integration tables of cost estimates. And this tool, that's torch, which is used for combining data and transferring data. So data in VDC Viewer are introduced in the VDC Viewer with this tool. Virtual reality, so this is a form of communication and data integration that is used for every project, and we use equipment. And Revit model with Enscape is displayed in virtual reality. We also use QR codes, and when you use a QR code, you can quickly share a panoramic image of the project. And that's all from me. Thank you for your time. If you have any questions, please contact me. Thank you, Robert. The next presentation this morning is Patryk Kajdrowicz, RTK system, how drones are revolutionizing BIM. Welcome. My name is Patryk Kajdrowicz. I represent RTK system. Our customers are large companies. I would like to say thank you for this possibility to be with you, and taking into account the group of colleagues I am here with. It is my great. I'm really happy to be with you, and I will do my best to get you interested, involved in my presentation. I believe drones are going to revolutionize BIM. And this GIS awareness in Poland and CSP and BIM, so these things are equally treated as some kind of phenomenon, but the drones can cooperate perfectly. They can significantly improve the work. But on the traditional construction sites, they are also very efficient, and how drones can increase the construction processes. It has already been discussed in the previous presentations, like yesterday, like the digital twins, a great presentation. Let me only discuss the drones. So analyzing an investment process in BIM, it is clear that we need to involve on all stages of the investment, in the designing phase, construction, operation, and demolishing. So how to analyze the process, and I believe that the drone should participate, should be involved on all stages of an investment. So that's the true for designing, construction, operation, and also the demolishing of the facility. And experts and engineers on international level accept this drone revolution together with BIM revolution. So that's what we have also had on the previous days from some companies having some Scandinavian experiences, and the construction industry has been using drones, and they are aware of the benefits, particularly in the land surveying phase and inventory taking of facilities, but also inspections of unavailable locations. So using of drones can also go further, so we can seamlessly integrate them with BIM processes to increase the level of efficiency in the entire life cycle of a facility. But starting from the beginning, drones, so these are manless aircrafts, and so they become more and more secure, automated. This is also as a BIM automation process, and practically they are autonomous. But now law does not allow to do fully autonomous flights, but shortly in the future that's going to change. And in the design phase, we use drones in construction industry has been widely tested. They are used for land surveying, for measuring of facilities, for historical areas, but also for difficult to access areas. And measurement of area with a drone is based on photogrammetry, and you start with some photos, taking some photos, and they are processed with software, and as a result of the processing you get a dot cloud, and this can be further processed to create a network of mesh. It can be a basis to model a facility for the purposes of construction industry, and from the cloud you can generate a numeric models of terrain, and you can also use some software to create numeric model. It is also important that with a drone you can integrate those measurements with the measurements with a laser scanner, and this will even increase the availability of the dot clouds, and the measurement accuracy can be up to 1 centimeter or 1 terrain pixel, and laser measurement, this is accuracy of 1 millimeter. So this combination of these two technologies will generate impressive results, and the volume of data gathered with manless aircrafts can be used for designing of construction works, and this can generate a lot of different options. And the next stage, this is the construction phase, and here, so there are some new circumstances and this is where you can use drones for monitoring, controlling of progress of work in the operation phase. Of course, regular verification of the construction and the design is needed, so the videos from drones can be uploaded to the cooperation BIM platform and automatically shared with all stakeholders. You can also do next measurements, further measurements, or you can compare these with the design. So you have a full control over the construction site without the need to be on site. So the international aspects of the projects, that's important also from this point of view. And another application of drones, it is safety and ongoing monitoring to reorganize works and to prevent accidents, etc. And finally, you can optimize the operation, the works on the construction site. In the third stage, it is management, facility management. So a lot of problems can be faced, like a long construction phase. It might be the case that some people will not be on site again. So all these so transfer of information may make some data to be lost, so you will be able to update the information, and it will also help to carry out the works. And on the operation phase, other tools can be used, like thermal cameras or PV panels. And in the demolishing phase, you can use drones to monitor the demolition or to monitor the risks in the demolition phase. And let me show some photos. So this is the designing phase. So this is a map and the underlayer, a Google underlayer, and so incorrectly carried out mosaicing. So some parts of the elements are included, others are not. So it shows how important it is to have the up-to-date information for the planning phase. And the construction phase, again, the drone. This is just for your information picture, but we can also generate some detailed photos, so you will be able to assess. And the operation phase, so the sound panels can be verified, so that's a very useful tool. And the technology New technologies are not cheap, obviously. Our company, to break the enter threshold, found the most common solutions, and as a result, today we are based on the accurate precision UGCS. We are also a distributor of this solution in Poland, and so this is also our equipment for photogrammetry, equipped of the system of accurate data collection, and in the base station in the middle photo sending information to the drone, so you will not have to use the reference stations, and the drone position can be identified with the accuracy up to 1 centimeter, and also the receiver on the last photo. So this is a standard receiver for land surveying works. And our system, in fact, does not require setting of points or reference points to. And below we have the manufacturers of software. We use, majority of them are known to you, and these are the results of our works on road construction. So this is the first photo showing from the platform level. So unmanaged equipment, and up to 1 centimeter, allowing you to verify the works. And the third photograph, this is a dense dot cloud showing that looks like a photo. This is a parametric model, and all kinds of measurements, distances, volumes can be calculated, and you can make comparisons with your design. And this is an image showing what it looks like in the field, and of course we can offer accuracy, precision, time, wide range, and safety. And using of drones for railway projects, this is that was reinforcement of slopes of railway line. And the first, this is a terrain area, high grass, and also sliding grounds with very undense aggregate. That was in autumn, so that so also the ground was very important. So instead of sending land surveyors, we did a 2 hours flight, and it was enough to verify the area. And next, we developed a dot cloud, and finally it was transferred to the designer who was working to reinforce the terrain. And the last photo shows how this tool can be helpful for sliding slope. So from the land level, you will not be able to develop a drawing like this. And as for the buildings, we are usually responsible for documentation of the construction process, but we also do some measurements on the land, on the earth, the works level. And the last slide, these are the measurements of volume. And frequently, on the roads project, when we do orthophoto maps, we do some flights, and we take some images for piles, and we are able to provide data on the condition of the piles and slopes to the construction managers. So summarizing, drones have a lot of applications. They facilitate construction works. They increase safety. Definitely, they shorten the working time, and they provide data of the same accuracy or even more data than traditional technologies. And now coming back to the revolution, I think this will be based on the fact that the drones will be a standard for investments throughout the life cycle sooner than BIM. And the drone data will force investors to use drones. So I'd like to recommend you using of unmanned vehicles, and that's all from me. Thank you very much. Hopefully you were able to hear what I was talking about.
Next presentation will be titled Geosolutions Platform in Transmission Grid in Piła, Elbud, and Mr. Jacek Klanowski from Pile Elbud will be presenting. Good morning. My name is Jacek Klanowski, and I work in Pile Elbud a company doing electrical energy construction. We are specified in high voltage, doing mainly transmission stations, power stations, wind farms, and energy banks. Our clients are Polish energy networks, Tauron companies doing energy transfer. A few words about Geomatrix Software Solutions company from Wrocław. It's a company which created a system for us for comprehensive management of database on line linear projects. Problems for us were distances. An average line is about 100 kilometers long. What is the presentation going to be about? It's how we moved from a distributed database based on Excel to central database where circulation of documents is happening in one platform, one location. Brief history of how we did it. Until 2014, we worked in distributed databases. Since 2014, due to many errors and problems in such structure of work, we built something like a central database on a server, and for this we used systems which we had in company available, generally available open systems. Such work proved right, and therefore in 2017 we decided for the whole system to be brought to order, to create something comprehensive. Geomatrix Software Solutions helped us creating a central database in the cloud. Briefly, how we understand BIM today, it was slightly different than understanding of BIM from many presentations so far. First, we understand it as a cloud, as GIS systems, especially web ones. We understand it as structure of GML-based databases and as 2D. Briefly, why individual elements are needed for us for building systems by us. The cloud allows remote work. If you think of remote work, the cloud is the best solution. Cloud is cheap. To browse the cloud, to manage database in the cloud, it's enough to have an internet browser and the license for cloud. VPN is second level. It's in our company creating such system is expensive. Therefore, we went to the cloud. I'm not talk too much about GIS systems because much has been said so far. I'm presenting what is most popular today. The COVID map is a superb example of WebGIS and utilization of these tools. Everybody knows this map. I think this is best GIS presentation. And about GML, in this presentation I have too little time available to say much, but very briefly I would like to share that this is a form of recording database used by Polish surveying and thus creating their own formats. We are using it is a copy of land register in electronic form, 2D or 3D. We are at the stage of 2D, but in cloud, so we design everything based on central database. We create our own 3D browser in the cloud to watch certain elements, and we will be implementing everything in 3D. For sure, how using or combining these tools allowed us to create various innovative functions. One of them I will present. It is a function of building central database on the project. It is a function which will allow us to start work on a large infrastructural project like road line, power transfer line, and to prepare for getting a construction license. How this function works, I prepared a small film, a small video. Do you see it? I hope yes. The video presents establishing a central database on the project, what we did. What we do in this video, how we establish a project, how we import GML, how we introduce the root elements, and how we carry out the process of automatically building the database. So as a result of such a process, database will be built about all real estate under the transfer line, power transfer line, then surfaces and used land database about owners will be generated. Owners will be combined so that in one project we, for example, avoid having 5 Mr. Smiths, just to have one. And so that we can see what land plots, what real estate that gentleman has, and what we are obtaining for them. And process of building the database is the first process. On a database built like this, we work and we generate the whole history of the project by adding the basic map, design elements, and history of negotiations and results of coordinations with other owners are introduced, owners of land plots along which the route is to be going. We coordinate everything. Once we conclude the design process, then the database is passed on to the real construction phase, and there further protocols are added going to the site. We can attach documentation from drones, orthophoto. And why we did this? Because we were looking for a BIM which is really profitable. So we want to use to a maximum extent what is available in the market. That means national geoportal, data from Google Maps, open source. And we didn't want to introduce them because with such big projects where we have 1,000 to 5,000 activities on the project, we decided it was easiest to buy it and import it. A central database, as a result, automatically geoportal was established for the database. UMSs have been attached, standard layers have been attached, like administrative borders, borderlines. Here we can see downloading data from the portal. In a moment you will see data from open available map. And here about documentation, we decided to commercialize the tool. So if some companies would be interested in this type of platforms, please be invited to contact us. Pile Elbud. So that's all from me. I said everything I had to say. Thank you, Jacek. Thank you for your presentation. And before we move on to the last presentation today in the plenary session, I would like to briefly wrap up the whole infraBIM event. Well, after the break, we have 6 workshops. I planned this agenda myself, but we do not have any special closing session, which usually appear at traditional conferences. But please tell me, what, in such circumstances, we happen to be organizing this event, this year's infraBIM. What could we do practically in how so far we could do anything in a traditional way like all other conferences? Nothing. Planning in February, planning the whole event in the original May date. The scenario looked completely different. It was supposed to be the first in Central Europe Expo and multi-conference on digitalization of construction. But at the beginning of March, I knew already that it would not work in this form, and we would have to shift everything over to October. We hope that in October, the hybrid form will be possible to be done. Maybe not 500 people would come as planned before originally, but maybe we managed to gather 100 people live at least, and the rest would be online. But everything changed highly dynamically, and as we can see, it's still the case. So we used everything what we had available to do an event which even in an online version would be different from all the other ones. I think we have succeeded, and actually we had, together with our young team, learned quite a lot. But thanks to cooperation with Arena Gliwice and Shadow Company, we achieved something that has been very positively appreciated by you. We read it in the comments, we read. And this was the point. We didn't want to do another webinar where with boredom you watch faces with poor sound quality, and students participating in remote lectures know what I mean. We did something completely new, and this not only in the scale of our country, but also in the scale of Europe. The big input in making it international was support from British embassies of our region of Europe. And here, thanks go to Ms. Sylwia Piwovar, who was with us on the first day, but also to Piotr Seges from SPI and Piotr Dudek from Association of Polish Technicians in Great Britain. It was a truly great adventure for me for a month. Well, almost a month, we realized the idea for smart infrastructure. Such an event had not taken place in this part of Europe, and this is what we started our infraBIM from. The second day was BIM Hyde Park, and very personal involvement by Ms. Justyna Pożarowska, but also from the whole team of Public Procurement Office, headed by Mr. Hubak Nowak, the president. It was an honor for me to meet you and work together, and the present words about the adventure with the digitalization of construction industry, which we started together, and about people who are most important in this process, will be a guideline for me in my further activities. Today, Dariusz Kaśnia is not with us here. He's preparing further lectures on BIM, and Dariusz Kaśnia involved in digitalization of BIM, but thanks to the fact that he trusted me, he believed that even in such difficult pandemic circumstances, we will manage. Darek, thank you very much for cooperation, and I hope we did manage. A little bit of statistics at the end. Usually, most traditional conferences mean 1 or 2 days with some dinner. We had as many as 4 days, and with a very tight program, which has never been spoiled, with one exception of what is happening now, because it is quite a spontaneous wrap-up you are watching. Over that period, we had almost 40 presentations, 20 workshops, and several very important discussion panels where we grouped quite a lot of representatives of central offices or experts from abroad. Our speakers and panelists participating in the Europe in discussions were experts, greatest experts of BIM in Europe, and also experts from our region, like Rail Baltica or CPK projects. When opening infraBIM, I was talking about 600 registered participants. We had lots of questions, and questions about possibility to join us. These questions are still coming, and that number quickly exceeded 800 people from 24 countries, including so distant countries like Australia, Egypt, Peru, and Vietnam. This exceeded our expectations many a time. Thank you very much for this level of interest. This encourages us still more to work, and for sure we will prepare something still more interesting, still more attractive, and regardless what form it takes. These over 800 people, of course, it was not the number of participants accompanying us all through all these sessions all the time. The time for analysis will still come, but peak achievability was 420 people, but the average was around 300 people. Well, I think it's enough of figures. They are impressive anyway. I would like to thank all institutions and organizations for their patronage, especially Ministry of Development, Ministry of Infrastructure, Public Procurement Office, GGDK. These are also the main institutional partners like Silesian University of Technology, GZM Metropolis, and commercial and media partners. I would also like to thank the teams of Arena, Gliwice, and Shadow Company. This was really full professionalism, which has already been appreciated. And finally, I would like to thank the young infra team. You have proven to be a good operator for such a big event in extremely difficult and unusual circumstances. I would like to thank you very much for cooperation, for assistance, support, and are we going to do the next event? Well, so many comments of me. We have to go back to the agenda because we have exceeded the limit. Kamil, sorry for the delay. I hope you have not been offended. And let me invite you, Kamil Korus, Silesian University of Technology. We have only got one presentation from Silesian University of Technology, although organizing, so optimization of arch bridges with the use of graphic designing tools and generative designing. My name is Kamil Korus. Good morning, and I am a PhD student at Road and Bridges. Let me tell you about optimization of design with the use of graphic designing and generative designing. Two techniques stronger and stronger related to BIM. This will all be presented based on the example of arch bridges. Thinking of complex structures, we in most cases think of atypical structures, but also bridges in engineering practice may be considered complex structure. So apart from parameters related to dimensions of the whole design or dimensions of cross-sections for an arch bridge, you may select various suspension systems. The number of variables which finally decide about the shape of an arch bridge is large, and through this, optimization of such design, of such structure is getting strongly complex. And actually in such a situation, one may use techniques of generative designing. Over the recent years, following stronger and stronger computerization and development of tools, approach to the designing as such is changing. Traditional designing often happens to be replaced by parametric designing. That means the one you know from BIM tools. And in turn, the parametrical components often are used for creating calculation algorithms which still stronger automate this process of creating models. This may be named calculation designing. Such algorithms, facilitating algorithms, may be used with graphic programming. It is useful because many tools for modeling cooperate with some environment for graphic designing. Here, for example, we can see part of Dynamo program. That means program or fragment of script of Dynamo program. That means program which is often used in the environment for modeling in Revit. Such algorithms for graphic modeling are created by connecting the blocks visible here, representing various functions, various roles. Mastering such graphic software is much simpler compared to mastering a typical textual programming language, but it also can facilitate many tasks. However, back to the way of designing as such, earlier presented techniques can all the time be considered the passive approach. That means such when man must decide about selection of all parameters, so practically regarding shape of the whole structure. Apart from passive approach, we still have availability of new active approach. That means discussed by me today, generative designing, and according to it, roles of algorithm are changing a bit. That means the computer and the designer, the human designer, has to establish the range of possible values for parameters and goal at which the algorithm must be aiming. But the algorithm is selecting optimum values itself. They are selected using optimization algorithm. And here in this case, it is a genetic algorithm. In a moment, I'll show you how such an algorithm works based on the example of an arch bridge. In our optimization case for an arch bridge, two quite classic optimization goals have been assumed. The first one is minimization of material consumption, and the second is maintaining the strength safety conditions in order to facilitate creation of geometrical models, beam models for arch bridges. Dynamo graphic algorithm was created, which enabled quick generation of models based on parameters introduced. These parameters control, among others, the span of the bridge, its width, and the height in arch and number of suspensions, all dimensions of individual elements in cross-section. Apart from creating the model directly from the algorithm, you can obtain a variety of data. Among others, this needed volume of material needed for optimization of the process. A model created in such a way may also be used for automatically generating calculation models. The way in which strength calculations are carried out within the algorithm creating geometry is most convenient, most effective, because it allows direct combination of geometric model and calculation model. Here, there is no need to export or even to create, sometimes from scratch in external software, to create the calculation model. In order to enable such calculations inside the algorithm of graphic programming, our team created a package, that means a collection of the blocks representing the methods. And this pack allows to carry out static calculations and strength calculations. Thus, it provided a possibility to calculate indicators for consecutive rods of analytical models, and thus we could go on to optimization, taking safety into conditions. At this stage, for selection of parametrics, a genetic algorithm was used, which worked in generative design addition to Dynamo program. The process works like this. First, the designer establishes the pool and range of possible values of parameters, which will be controlled by genetic algorithm. In case of our arch bridge, these are 24 geometrical parameters. They control the shape of the structure and dimensions of cross-sections of elements. The very algorithm for creating geometry of an arch bridge has more parameters, but during this analysis, some of them were established as fixed ones, resulting from utility properties like span of the bridge or its width. So finally, the algorithm has availability of 24 variable parameters. Apart from parameters, designer establishes the function of goal. That means named also cost function. A cost function may be understood as a function of evaluation, based on which the algorithm evaluates how good are consecutively generated by it examples. According to this function in this example, the algorithm is made to possibly minimize the volume of material used, but it must also fulfill the safety conditions, that static safety conditions. So if the structure is not fulfilling such requirements, that means indicator of one of the elements is higher than 1, then cost of the material goes very high in this. Too high for this design, I mean, so that such a design is not acceptable for further analysis. Later, the algorithm, acting in iteration, in every next iteration, it creates positive examples. Here, indirectly, the algorithm is learning the rules of mechanics of the structure. After the given series of cycles, the best candidate is chosen. In order to test this optimization process, a test was carried out with the use of parameters of real structure. Parameters of structure were introduced into the algorithm, thanks to which the visible here beam model, geometrical model, was obtained, and data about cost of the material and indicators of use of groups of rods under simplified load, which in a simplified way simulated utility load on the bridge. Optimization was carried out through 100 cycles of the genetic separately through individual suspensions for vertical, radial, and mesh types. The first chart shows the cost value of all the structure in individual iterations. This is the value of costs according to the cost functions defined earlier by the designer or that person who created the algorithm. The second group, bar chart, compare cost for this optimized structure and designed one, and comparing indicators of utilization of all these groups of rods. And in the last chart with utility indicators, you can see in how clever a way the algorithm was able to lead to optimum usage of the most important groups of rods. So the largest groups, that means arches and bracings and cross supports, all have utility at a level of exceeding 90%. Such an even usage leads to optimum solution. Based on this, we can state that genetic algorithm clearly managed to cope with this uneasy task which had been put forth to it. Here, both beam models, so a model of benchmark structure and the model of optimized structure, that means one with parameters selected by algorithm during this process. And finally, wrapping up, both techniques displayed here, that means graphic programming and generative programming, may be very useful in automation of various kinds of tasks, design tasks. Generative design is one of the ways to support designer in decision-making process, but it does not actually relieve of all the burden from him, but changes the hack work on iteration processes, all the time demanding engineering creativity. Thank you for your kind attention.
Thank you, Kamil. That was the last presentation, and now we are going to have a Q&A session, and you might have seen the change in our background. And this is what we are going to have next year in May. Let me invite you to the first Central European Bridge Fair, InfraMost Fair, Expo. Hopefully the situation is going to be safe enough for us to meet face to face, but definitely we will not give up with the online broadcast. Streaming will be offered, and this opens us to the world, and this opens we are going to continue with that. And a couple of days from now we are going to start a portal of this event, and we are going to start an information campaign, and in the break you saw the first reference materials on infrastructure investments, bridges. Those of you who know me, you know that bridges are, that's my passion, and so I will always be involved with bridges. So this is how we are going to change the discussion subject in the studio, but still we are going to talk about the innovations and digital technologies, and the Industry 4.0 is going to be our keynote. And so let's look at the questions now from the last session. Do we have the speakers in Zoom? Yes, we have some questions. We have the speakers with us. A question addressed at Robert. Can you hear us? Yes, I can hear you. Can you hear me? Krzysztof is asking, BIM and Applica, is this more like level 2? I'm not sure if I interpret this question correctly. Yes. Generally, let me briefly explain. The level 3, it has full integration of the project data, keeping it in the common environment, and it is available in real time by all team members. Very important here is whatever is happening in the project, the real time gives us this comfort of keeping control over the project with up-to-date data. And what is very important for level 3, a model after the designing process is transferred to the buyer to manage the asset information model. This is generally the goal of the level 3, but one sentence more about other levels, like level 0, practically there's no cooperation. That's what is common for the level 0. More CAD drawings and producing of information. In level 1, usually involves connection of 3D models for conceptual works, and separately to them for documentation and developing of design drawings. And in the level 2, now it is the most commonly used, and it is a full coordination, and all data finally need to be put into exchangeable file. This is IFC or Corbit. So these are the two standards which are internationally acknowledged for information sharing. So that's the level 2. And the level 3, as it has also been discussed at the beginning. Thank you. Patryk Kajdrowicz from Karol Buchholz. How long does it? So, what is the time frame operation? What's the operation time of a drone, and how long does it take to scan, like, say, let's say 5 kilometers of roads? Sir, I cannot hear the gentleman. I will not be able to interpret this. Patrick, again, could you be closer to the microphone? Okay, I will be speaking louder. Can you hear me now? Yes, that's better. So generally, within 1 day, we are able to do scanning of 5 kilometers of a road. Of course, with the assumption with the terrain conditions are not very complex. Of course, you need to take into account also the legal requirements. So 1 day, absolutely, and this is enough to scan 5 kilometers of a road. Jacek from Paweł. What is the name of the software you have been presenting? Do you mean the transfer one? The question is...
solution.
What about the calculation of pipes? I believe that in the graphic software, if this package was implemented, you can also carry out this calculation. I did not do that analysis, but this mass package, what you do with the graphic software, what kind of script you generate, so it's up to you. So you can do these calculations with a mass package, not only for bridges, but also you can do it also for buildings. So pipes can also be elements of bridges, particularly arch bridges. And next question is again for Robert. Arkadiusz Leśko is asking or request, could you extend on what SOCI files are? My impression is that most people do not know the standard, and it is very useful for buildings and for infrastructures. Yes, we have been using SOCI due to the fact that the majority of our projects are carried out in Norway, and this is the standard which for many, many years have been developed there. And so this standard is also included in British standards, so this is not only a Norwegian standard, but it is also believed to be international. SOFC, it is also used for vector maps and for geospatial data. It is mainly used to geographical information sharing, geographical data sharing. And this standard includes normalized geometric definition and topology and the data quality and attributes and metadata and coordinates. So it is practically optimum, maximum solution if you have topography, and so all projects do have some topographic elements. So it is an open standard. It was developed by Norwegian Office of Cartography. I think it was like more than 20 years ago. So for a long time it has been in use, but it is constantly developed and updated. So I believe that it works really good. And as mentioned, the ISO also mentions this standard. We are very happy. And SOFC, when you download it from Holda Data, that's a Norwegian portal, so it will be converted and it will go through some BIM tools, and it will be fully available to use in Revit, and it can be used in a project like a terrain model. Thank you. Robert, are you broadcasting from Sanok or Norway? Yes, I am in Sanok, in the town of Sanok. So I returned back home via Warsaw. So I'm saying hello to you. Yes, but it's this is the same exotic as in Norway. Next question goes to Kamil from Karol Buchholz. Could you extend on genetic algorithm? We have very little time, so very briefly. So this algorithm, as I showed, as I demonstrated, this is an algorithm which, based on the pre-uploaded parameters, will look for optimum values and parameters. So this is an algorithm which can be also compared with other algorithms. So these are algorithms which will be searching the space to find the best match. This is how it works. So you can also combine this with machine learning. So this is I would describe it as an intelligent, smart algorithm. Next question to Robert, a very long one. Let me read it. LOD. Oh, let me rephrase it. LOD. Very frequently, I experience that in architects' work, CAD drawings are full of some details which are not necessary. One of the blames I often hear is that Revit is ugly. You can do something with that, but frequently you will have to increase the number of details. But this will also involve some extra time, and you need to have the modeling skills or better computers. So do you have any piece of advice to convince more conservative designers to less defining, or to fewer number of details? So let me answer this as follows. Like LOD, it is how you define the level of details in modeling. You need to define the scale. It is the detail, how many details you have in a flat drawing. And of course, when you transfer to 3D, a lot of CAD drawings are now in BIM documentation. And of course, now more and more details are created as models, not as separate drawings. But generally, for modeling and defining of the level of details, you need to define the goal of a model, how significantly it needs to be detailed. and what are the purposes for the model. So if you want to generate one drawing from a model, flat drawing, with some kind of details, there is no need to model all those details. So the model can be smaller, like let's say LOD 300, and you can stop modeling and you can go to drawing of details. This is so it can be very broadly discussed. In Denmark, when I used to work before at a university, the constructing architects, so detailing of architectural elements using BIM. So that was the foundation of the educational process. And my suggestion would be for those of you who do modeling, so you can watch some YouTube videos what detailing in BIM is. So this is a very extensive subject. So in Revit you have annotations, and the basis for good detailing in a drawing in Revit is understanding of functionalities of the software and 2D libraries and components, like in Revit. Over-detailing, yes, it may happen, but this is the experience of architects and constructors. So over-detailing, so you need to have some experience and you need to base your feelings on what you need to demonstrate in a project based on your experience. And the last question from Krzysztof Wojciech to Kamil. I hope the answer will be short. So what software did you use for calculations in generative designing? Was it Carenda? No, that was Dynamo. That was generative design additive. It was also used for as an additive to Dynamo. How many iterations did you do in the software, taking into account that 24 parameters were taken into account, and what was the total iteration time? So we had 100 iterations, 20 cycles. That was my computer was used for that. That's not a calculation computer. So these iterations took roughly about 8 hours. To carry out. We did also some other analysis, shorter ones with a fewer number of parameters, like for selection of cross sections, like we had 50 iterations, a fewer number of parameters, and that was like a couple of hours, 3-4 hours. Importantly, all these analyses were offering us optimum results versus to the reference original model. What algorithm did you use? Carol is asking. Algorithm, genetic algorithm, generating design, and the calculations, static calculations, our own package, mesh package based on available static C# brief finite element methods. That's all about the questions. For those of you who are interested in the algorithms, Kamil is representing also Marcin Jasiński and myself. Marcin is more expert in algorithms, and in early November his PhD thesis hopefully will be published, and hopefully in January he will be his PhD work will be finished. But he is more expert also in digital twins, and thank you for being in the presentation. Thank you for the discussion, and after the break we will have 6 workshops, very interesting ones. Be with us after the break. Thank you.